We've done a lot of work with slope. In fact, we know 4 ways of communicating slope. There's the change in y over the change in x. That's one way of verbalizing slope. Another form of shorthand is delta y over delta x. It means the same thing. It means slope. Change in y over change in x. Delta stands for slope. Bailey, will you put your computer away, please? We also have rise over run, which is when you have a graph, a picture. You count the rise over the run. We also have another formula, y2 minus y1 over x2 minus x1. Now that's not to be confused with yesterday's midpoint formula. The midpoint formula is completely different from slope. So there are 3 things that we need to remember about slope. One is that it's always a fraction. Slope is always a fraction. Slope is sometimes improper. And slope is never a mixed number or a decimal. Slope is always a fraction. Now you say to me, wait a second, Mrs. Long, what if it's 3? Like, what if the slope is 3? Can you make 3 into a fraction? 3 over 1, right? Slope is always a fraction. Sometimes it's improper. Not always, but sometimes it is improper. The numerator is greater than the denominator. But it is never, ever, ever a mixed number or a decimal. Now we have a new vocabulary term. Intercept. Remember we talked about this? Mathematicians are not creative people. Man, my spelling is awesome today. Intercept. Mathematicians, not a creative group of people. In order to use slope-intercept form, you have to have a slope and you have to have an intercept. Intercept is the point where the line crosses the y-axis. I know, the lag is really bad. The intercept is the point where the line crosses the y-axis. Not the x-axis. It's always, always, always the y-axis. So, big deal today. Slope-intercept form. Slope-intercept form. This needs to be committed to memory. If you memorize something this year, this is it. It's a big deal. Y equals mx plus b. Someday it'll show up. Y equals mx plus b. M is the variable that represents slope. N is the variable that represents slope. And it's not just b, but plus b is your y-intercept. Because it could be a positive value or it could be a negative value. Let's see if I can unconnect and fix this. So it's always in the form y equals. There's always, not always, but 90% of the time an x. The m value, so the coefficient of x is your slope, and the constant, the plus or minus number, is your y-intercept. Big deal. Memorize it. You're going to use it for every single problem.
Ever in the world.
Well, today. Slope-intercept form. All right, we're going to do some examples. The first part is just the identification part. The first part is just identification part. In the formula, y equals 1/2 x minus 3. Remember, we talked about this when we did functions. If the formula is in y equals form, it makes it easier to graph. And this is why. Today you're learning y. What's your m? What's the slope in this equation? 1/2. What's the b in this equation? -3. You got it. The coefficient is your slope, which is 1/2. And the constant, the plus or minus number, is your b. Y equals -8 plus 2. This is Molly. What's your slope? It's -8. But I said slope is always a fraction. So can you make it a fraction? What? -8 over 1. Do not make it -8 over -1 because two negatives create a positive. This is a negative value, so we only want one negative. What's the b value? +2. I don't need to put the plus sign because positive is implied. All right, let's try this one. Y equals 4. What number touches the x variable? If you needed to make it a fraction, it'd be 0 over 1. And what's the plus or minus number? 4.
Is it 4? I got 1.
Last one. Y equals 3x. What's the slope? 3, make it a fraction. And what's the intercept? Because there's no plus or minus number. Half of it. All right, so we're going to really quickly graph these. And your graphs are not going to be pretty. It's okay. This is Molly. Hi. Huh? Yeah, I can do it. Yep. All right, here we go. Draw the graph sometime. So on your graph, your y-intercept is -3, so we go to the y-axis and put a dot at -3. Always the same procedure. Start with the y-intercept. Then from that point that you put from the y-intercept, we're going to count the slope. And slope in a graph, in a picture, is rise over run. Rise over run. So from this dot, I'm going to rise 1 and run 2. And you're going to rise 1 and you're going to run 2. They're both positive, so you go the positive way. My rule is you must have at least 3 dots. So do it again. Go up 1 and over 2. 3 is better than 2 because it makes your line straighter. Now here's the deal. If I want to put 4, because that's going to make my graph perfect, I run out of room. I can't go up 1 and over 2. I'm off the graph. But I can do the opposite. Instead of going up, I'm going to go down. And instead of going to the right, I'm going to go to the left. Because, ladies and gentlemen, my slope was 1 over 2, which is up 1 and to the right 2. But it's the same thing as -1, -2. Because 2 negatives cancel out to make a positive. Connect the dots extending through the graph to make a line, and there's your graph. Draw another graph for the next one. This one's going to have look a little bit like this. One, two, three, four. 1, 2, 3, 4. 3, 4. 1, 2, 3, 4. 6, 7, 8. Pay attention, gentlemen. It's the same procedure that we did on the last one. I'm going to start with the y-axis, the y-intercept. The y-intercept is 2. So I go up 2 and put a dot. That's my beginning point for our line. So now my slope is -8 over 1, which is rise over run. So how do you go up -8? Can you? No. What is it? Down 8. 1, 2, 3, 4, 5, 6, 7, 8. I go down 8, and it's a positive 1, so which way do I go now? To the right 1. Now this graph is different. I said always try to get 3 dots. This one, the slope's too big. I can't, so I have to make do with 2. But if you notice, This is a negative line. My slope is negative, and it is negative. If I look, it makes the diagonal in the letter N. Let's make another graph for y equals 4. You can do 4 to each side. And just like everything else, I start with my y-axis. Every other problem started the same way. You always go first to your y-intercept, which is 4. So I go up 4 and put a dot. The slope for this line is what? 0 over 1, meaning I go up 0 and over 1. So up 0 over 1, up 0 over 1, up 0 over 1. So up 0 over 1, as many dots as you can. What kind of line does it make? It makes a horizontal, because a horizontal line has a slope of 0. If I wanted more dots, because the more dots you have, the straighter your line is, instead of going up 0, I can go down 0. Doesn't do anything, right? But instead of going to the right one, I could go to the left one. There's going to be a point in time when the more dots you have, the better your line is, because we're going to be looking for specific points. All right, let's do this last one. Let's do 5 each way. And in this last graph, we start with the same spot. You start with your y-intercept. That's always your starting point when you're graphing slope-intercept form. And this time, the y-intercept is 0. So at the origin, I put a dot. And the slope is 3 over 1. Meaning, from this dot, I go up 3 and over 1, positive 1. I need 2 dots, but I can't fit 2 dots going up. So I have to do the opposite. So I go back to the origin, to my intercept, and instead of going up and to the right, I'm going to go down and to the left. What you need to be aware of are 2 really tricky things. If the equation says y equals, like this third one we did, anything that has y equals and no x value is a horizontal line. Because every ordered pair on this line has a y value of 4. The x values are all different, but the y value on the y-axis, it never goes past 4. If it says x equals 2, if it says x equals any number, right? But if it said, I'm using 2 as my example, what kind of line would that look like? Vertical. And what kind of slope do vertical lines have? Undefined.